Hi and welcome to today's video. This video is a response to some of the comments I've had about the eBay Prusa i3 printer. People have been asking what the Slic3r settings are and what firmware I'm using. So there'll be a link in the description of the video to my public Dropbox space for the download of the version of Marlin that I use on this printer. And what I'm going to do is I'm going to go through the Slic3r settings step by step so that if you want, you can replicate my settings on your machine. Just one thing to note, the first layer prints really slowly, so that's pretty normal for my settings, but we'll jump straight in and we'll go to Slic3r. So here we are in the Slic3r Config window, and as you can see, the first tab is called Print Settings. I have a profile called 30mm a second, and under Layers and Perimeters I have layer height at 0.2, first layer at 0.3, vertical shell perimeters at 2 minimum, horizontal shells, which is the solid top and bottom layers, at 3 each. I find that works quite well. And the quality settings, I believe these are default, but the only one I don't have ticked is avoid crossing perimeters. I must try that one day to see what it does. Under the advanced options, I use seam positions at random, because I don't like to have that line up the print where each layer starts and stops. So I'll just move the mouse cursor out the way so you can pause the video if you need to. Right, so we move to infill. Infill density in this window is 25%, but that can be changed in the repeat your host window. I mean, you can just use the slider, as can the fill pattern. The top and bottom fill patterns I use rectilinear just because it's easier. Reducing print time, combining infill every one layer. I believe that's the default setting. I don't use anything different on that. I've never tried messing with it. And the advanced solid infill every 0 layers. Fill angle 45 degrees. You can mess with the fill angle if you want to put your part on the bed at 45 degrees, because what you find is the infill will be in line with the edges, so you might want to change that. It's not very often you want to do that though. And solid infill threshold area of 70mm. Now what this means is, if the area of the layer is less than 70 square millimeters, it will just infill it solid regardless of what you want. Now 70mm squared is pretty small, so you know if the printer starts doing weird stuff when you're printing really small items, just reduce this number and it'll make it all good again. Now I only retract when crossing perimeters, and I don't infill before perimeters. I've never tried that. It might be quite interesting. So there you go if you want to pause it. Right, skirt and brim, 1 loop minimum. Distance from object is 6, and the skirt height is only 1 layer. That's just to kind of like clean out the nozzle when the printer first starts. And the minimum extrusion length is 10mm. I believe they are all defaults. Okay, the brim width, this is if you have problems with the part lifting off the print bed, just add like 10 or 5mm to the brim and it'll make the first layer 5 or 10mm wider, but don't worry about the distance from object because that gets updated automatically. So there you go if you need to pause it. Support material is turned off because that all gets controlled in the repeat your host window. You just turn it on. I believe all of this is default, but if you want to switch it on and set them all to the same as what I've got, there you go. Speed. Now this one seems to be what everybody wants to know about. What print speed do I use? Now the profile's called 30mm a second, and that's what I print at, 30mm a second. Now when you change these values, it's really important on the ones that have the percentage sign to put the percentage sign in, because if you don't, it'll use that as a millimeters a second value. Now for this one, perimeters is 30mm a second, and small perimeters are 70% of 30mm a second. If you would just type in 70, it's going to make small perimeters 70mm a second and perimeters 30mm a second, which is not right. Small perimeters should be slower. External perimeters is the same at 70%. Infill is at 40 because I want the infill to go faster than the perimeters, because I'm not really bothered about the quality of it. You could put that in at a percentage of like 110 or 120, but I just wanted to control it with 40. Solid infill is 75% of your I can't remember whether it's the infill value or the perimeters value, but it's one of those. But it definitely needs to be slower than whatever that value is, so don't forget the percent sign. And top solid infill 50%, because the slower that goes, the better the quality is. Well, up to a point. If you go too slow, you'll just melt it, so I use 50%. Support material I print at 20mm a second, because sometimes the support material can be really tiny, and the slower the better. Bridges 40mm a second. The reason I do that is because I want to try and stretch the filament as it's bridging, so it doesn't like sag down so much. And gap fill 20mm a second. I have no idea what gap fill is. So speed for non-print moves, this is 80mm a second. So that's when the printer's just kind of like moving from the end of one layer to the start of the next, or from one part to the next if you're printing multiple parts. You want that to be quite quick. It doesn't really make a lot of difference. The first layer speed is 40%. Now this is 40% of the 30mm a second. So that's around about 15 to 17mm a second for the first layer. So if you're printing something big and you wonder why the first layer takes an hour, it's because this is running at 40%. Now, I find it's slow. Yeah, fair enough, it is slow, but it does aid sticking to the bed. It helps a lot. Now, the rest of it, they're all switched off because the acceleration control is switched off. And the only one you need to worry about is max print speed of 80mm a second. If you increase the travel speed, then I believe you have to increase the max print speed as well, or it just doesn't go faster than that. So multiple extruders. This printer has one extruder, so it has 1, 1, 1, and 1. Ooze prevention is turned off, obviously, because we don't want ooze prevention with one extruder. And interface shells is switched off. Advanced, the first layer is set to, excellent, 200% over extrusion. Again, that's literally just to aid the first layer sticking to the bed. Infill perimeter overlap is over extruded at 15%. Over extruded? No, it's at a speed of 15%, which just means that when infill layers touch each other, it's going to go a little slower. And bridge flow ratio is 0.95. Again, that's to stretch the filament when it does the bridging. It extrudes a little slower. The others are 0, 1, and 0. Okay, so the output options are all default as far as I know, and the notes are empty. So that is the printer settings. So we'll move to filament settings. This is for ABS. This is the temperature I use for ABS. And if we go to filament, my filament diameter is 1.75. I have measured the filament, and it does vary a little below and above that number. So I just tend to leave it like that because it kind of balances itself out. And the extrusion multiplier is 1. Now, some people will change this extrusion multiplier if you're getting over extrusion problems or under extrusion problems. I tend to calibrate the extruder by changing the steps per millimeter. So you can do either way. Now, my extruder temperature is 230 degrees for the first layer and for the rest of the print. And the bed is 110 for the first layer and the rest of the print. You can mess with these and get the best results for you, but that's where you change them. Now, if we go to cooling, this printer does have a cooling fan because we fitted it, but I've got that disabled and I've got auto cooling disabled. And the only thing you really need to know is that when it's bridging, the fan should be at 100% speed. Again, that's just to prevent any sagging. But with it being disabled, it won't do anything unless you enable cooling. Now, I'll just leave that there in case you want to copy those values as well. And finally, under printer settings, the general tab for this, the bed shape, if you hit set, just set it to I think it's 215 square or something, or 220, or whatever size your glass is. Now this Zed Offset, I'm a big believer in Zed Offset because I level the bed with a piece of paper, and a piece of paper is about 0.1 millimeters thick. So when I level the bed to that, this minus 0.1 millimeters should compensate for the thickness of the piece of paper when you level the bed. If you find that your first layer doesn't stick properly or it's too thick, you can adjust this to 0.1, 2, 3, whatever. If you find that your first layer is too squashed, you can put 0.1, 2, 3, whatever. in there rather than mess about with the end stops of the printer. So that's kind of what that does. The capability is one extruder. The G-code flavor is RepWrap for Marlin and Repetier, and everything else is switched off. So we move to custom G-code. Now, I'm a big believer in custom G-code as well, because this should help save power when the print is finished. But the start G-code, we want to do G28, which homes all the axes. And then we want to do G1Z5, which lifts the nozzle 5mm, so that when it heats up and you get the little bit of ooze, you've got somewhere to kind of get in with your tweezers and pull it out. If you didn't have that line, the nozzle would stay flat to the bed and the ooze would just make a mess. Now, the end G-code. I find this quite important. So we're doing an M104 S0, which turns off the extruder. Sorry, the heater for the extruder. We're doing an M140 S0, which turns off the bed. We're doing a G91. Now, what this does is this changes the coordinate system of the printer from absolute to relative. Now, what that means is it will assume the position is then 0, so you can move up by 1 or 2mm just by doing a move of 1. And strange enough, the next line is G1Z1, which will lift the nozzle 1mm from the final top layer of the print. And then, of course, we need to do G90 to change the coordinate system back to absolute mode, so that when we tell the printer to do a G28 and go home, it goes to 0, 0, absolute, which is the corner of the bed. If you left it in relative mode to do that, it's just going to go back to the top layer of the print and stay there, which is not good. And most importantly, M84 at the very end, which will disable your stepper motors. So if you've had a problem with your printer where after the print's finished, the stepper motors stay hot, M84 stops them. It shuts them down, they cool off, and you know it's going to save power. And finally, under Extruder 1, the nozzle diameter is 0.4 because I've got the E3D Light 6 on the thing, and I've got a 0.4 fitted. If you got a Volcano kit for that, or if your nozzle is a different diameter, that's where you change it. You need to change it because the Extrusion Multiplier works out on filament diameter and nozzle diameter how much to extrude. The extruder offset is 0, 0 because we've only got one extruder. If you had multiple extruders on extruder 2, 3, 4, you would have to put an offset in here of kind of how far apart the extruders are. Now, retraction. This is something I've been messing about with quite a lot because it stops blobbing. It's the best way I can describe it is when a layer finishes or when a part finishes and it moves to another part, it will wind the filament back so there's no ooze. But if you wind the filament back too far, when it starts the next part, it will wind the filament forwards and kind of build up pressure in the heat chamber, and you get blobbing. So I've been using a retraction length of 0.8mm. If you're using 3mm filament, don't use 0.8. You need a lot more retraction than that, but that works great for 1.75. I don't do a Z lift on retraction. You can, so that the Z will clear the top of the model and then move to the next position and then go down again. But you get into backlash issues and stuff, so I tend not to do that. If you have a print that keeps knocking over, so like when the head moves, it knocks the print over, try putting a bit of Z lift in, like 2mm, so that it will move up and then go to the next position and then move down again. Of course, that's going to increase your print time. Retraction speed 35mm a second. That's the speed the extruder is going to travel to retract. I find 35, it's plenty fast enough. Extra length on restart. After it's retracted, if you find that there's a gap, put some numbers in here, like 1 or 2. If there's no gap, it's fine. Minimal travel after retraction, 2mm. So that's just how far the printer has to move when it starts the next layer before it will actually go through the retract thing. And retract on layer change, yeah, you definitely want to retract on layer change because you don't want anything oozing out. And that is pretty much it. That's all of my settings in Slic3r. Like I say, if you have any questions about these settings, feel free to ask us any comments. And I hope these settings work for you as well as they work for me. But as usual, please like, comment and subscribe. I've been Steve. Thanks for listening.